Hello, my name is Henrik Nordsyd. I have written a book about engineering in Bronze Age Scandinavia, and in this video I will present a section of that book.
In this video, we will look at the rock carvings from Åby and the boats that I have looked at before in another video, where I explored the possibility that these were an early attempt on using sails. It is possible that these are sails, but in this video I will show how these shapes can be turned into a navigation tool. With this tool, you have a compass, a clock or a sundial, a calendar, and a filter for sine waves. This YouTube series is made because I wrote a book on Barlastboats, a boat type that was forgotten. One of the main parts of this theory was that these boats were specifically made for open ocean conditions where there are large waves and you are far from land. But with this boat that was unsinkable, your life would still be safe. If you venture far out into the ocean, you will need a navigation tool as you lose sight of land. There are islands, Väderöarna, not far off the coast of where these rock carvings were found. These are far away, so you will lose sight of land, but not far enough so you can't get there with a ballast boat. The Sun Cross can be found on many rock carvings in Scandinavia. It is basically a cross inside of a circle. This is most commonly believed to represent the sun, and there are several things pointing towards that. But then there is the carving that I have enhanced. To me, it looks like a better depiction of the sun placed next to the sun cross. They even depicted a bird flying below the sun to show that it is in the sky. This can be an attempt to show that the sun cross was used with the sun, probably as a sundial. To explain this next part, there is no way of getting around using some math. So first, a simple explanation of sine waves. A sine wave is a wave that relates to a circle. To find a specific point along a circle's perimeter in a two-dimensional space, you can measure the two distances from the center out to the circle's perimeter, indicated by gray lines. One measurement to the side and one pointing down. You could get these points by using the radius of the circle, indicated as a red line, and then use sine to get there instead. The sine values could be seen as a stretched out circle. Now if you take some time to look at the figure, you can see that it is made of a sine wave, a circle, and some straight lines. This is a sun path diagram, and it looks a bit like a part of a sine wave. And there is, of course, a reason to this. It is because the Earth spins around its axis and is round, so that links it to the sine shape. As the Earth tilts, it affects the visible amplitude of the sine wave throughout the year. The axis on the bottom of the graph shows the rotation angle of Earth, and the axis pointing up shows the angle between the sun and the horizon. From this, you can get data on how high the sun rises at a specific time of day for a specific position on Earth. The time of day also gives the direction of the sun, or more accurately, humans have called the sun's position time when using a sundial. But for a navigation tool, understanding the cardinal directions of the sun is more important. Instead of calling it a sundial, they are sometimes called solar compass. Now back to the rock carvings. A very interesting rock carving can be seen in Solstice next to Åbyfjorden. The interesting part are the things sitting on top of the boat. These look like two roundish objects on masts. There is also a thing that looks like curved horns of some sort. We will come back to the curved object, but first start with the two round things. I think that they are not two round things, but one round and one straight object suspended on ropes. The objects have been turned, so they could be properly depicted. This is so they do not look like two lines when viewed from the side. To show how I believe the navigation tool was designed, let's look at the different parts. It consists of a circle that I will call hjul from now on. This is suspended on a mast. The next part is a straight part that I will call boom. This is also suspended in the air with ropes going to the top of the mast and probably down so that the height of the boom can be adjusted. In this picture, both rock carvings have been placed above each other. There is also a sun cross depicted on the rock carving. This is very important as I believe it shows the position of the sun and how it casts the shadow of the boom onto the hjul. Lines have been added to depict possible max angles of the sun during midsummer and midwinter. The orange lines show how the shadow falls from the boom onto the hjul. Both are within the possible angles of the sun for the area where this carving is found. With this, the shadow shows time, but most importantly, the current direction of the sun, if used on a floating boat. The boom is moved up or down throughout the year to calibrate it to the current angle of the sun. When these people were out on the ocean and had to know the direction of the sun, they could turn the boat so that it pointed towards the sun, and then they would know the current position of the sun. This could then be used to know where south was, and also how that related to the direction they wanted to travel. This picture illustrates how the shadow falls from the boom onto the hjul for midsummer and midwinter. The boom needs to move down when the days get shorter. For most parts of the world, without midnight sun, the full circle of the hjul cannot be used. Also, this navigation tool that I have chosen to call Nordsydtid works best in the northern and southern parts of the Earth, as it needs the sun to stay low. At least one mast also needs to move relatively to the other mast to calibrate the device throughout the year. Here is another illustration that shows what the sun will see for different times of the year. With this illustration, some functions can be discussed. The cardinal directions used in English is from the Viking Age, but it can predate that time by thousands of years if it originates from this device. This device shows that the sun rises and sets in the east and west during equinox, and during these 2 days, the hjul and boom forms a sun cross at sunrise and sunset. Equinox is the 2 days during the year when the night and day is equally long. These times were probably important, as we will discuss later. If you know the direction of the south and north, it is probably easy for a human mind to think of the perpendicular directions. In this illustration, the equinox days are shown by the hjul in the middle. To the left is for midsummer and to the right, midwinter. You would think that for midsummer times, the device would form a sun cross at 6 o'clock, but unfortunately, the time in Sweden is offset, and at best, if you live in the most eastern part of Sweden, this will be off by about 15 minutes. But for other more western towns, it can be off by over 1 hour. This is not an error in the Nordsydtid, but a simplification modern humans live by, called time zones. Another thing to realize with this device is that it goes down and up again during the day and shows both the west and east direction at the same time, but only one is correct. This means you must relate time or direction to midday. In Sweden, we have a word for before and after midday, förmiddag and eftermiddag, before midday and after midday. Have you ever wondered why your watch starts over at midday? It doesn't make much sense. The more known sundials don't do that, and the old civilizations in the Middle East relate to time as daytime and nighttime, and had a switch at sunrise and sunset. This would make much more sense, as it better correlates to sleeping patterns of humans. Today we have digital watches that can show 24 hours instead of 12 hours. So could the 12-hour watches with a split at midday be a remnant of the Nordsydtid device? I don't know, but for this type of watch, midday is crucially important to relate to. There are some more details on the accuracy of this device written in my book, but here are two illustrations on how accurate the device can follow the sun path diagram. The yellow dotted lines are calculated for a Nordsydtid type of device. To the left for the southern part of Sweden, and to the right, northern part of Sweden, where there is midnight sun. Depending on how well you calibrate the distance between the masts, different accuracy could be reached. Maybe you are concerned that the waves of the oceans would mean that the angles would be all wrong, as the waves tilted the boat. That is true, but this device needs to be turned in the direction of the sun, and that is easy to do if it floats. And if the sea is calm, then it will act as a spirit level, or in Swedish, vattenpass. Water will naturally form a flat surface and give you the correct angle between the earth and the sun. Also, when you are out on the sea, the horizon is not obstructed, and this too helps you calibrate the device. But what to do if you are out on the ocean with waves and you want to know where you are going? Surely this device is useless then. If you think that, then you need to realize that waves are formed like waves. This relates back to the sign part of the video, where waves relate to circular objects. Signal filters is something most people have not heard of, but they are basically electronic devices that looks at any signal and removes the part that is not wanted. Let's say you have a signal that says 1. This is also the center of the circle. Adding a sign function to it can result in it going from 0 to 2. If you know that you have a sine wave changing your results, and your signal goes from 0 to 2, then you can easily filter out the sine wave and conclude that the number you want is 1. Let me show you an old device that filters out waves. Now I have added one side of this device, I call it hornkikare, to the sign picture, shown as a brown horn-shaped line. You would use this staff with the two horn shapes by holding it closer or further away from your eyes, so that the top and bottom of the horns coincided with the top and bottom value that the Nordsydtid showed when the boat moved in the waves. Then the tip of the horns would show you the actual direction of the sun and thus filtering out the waves. This staff would probably seem magical to many people, and the person who calibrated the Nordsydtid and was in charge of navigations could walk around with this staff and show his skills, and it probably gave him higher status in the society. If you think waves do not form perfect sine waves, you are correct. But boats with inertia have eigenmodes. This means they will find a frequency and a rotation mode and want to stay there. This is more thoroughly explained in another video. There are additional indications that all of these parts were a navigation tool and that the person holding the hornkikare was in charge of navigation. Many have heard of 3D, and 3D comes from 3 dimensions. 1 dimension pointing forward, 1 to the side, and 1 upwards. It is used to explain where an object is in space. You can use your hand and fingers to point in the different directions of the different dimensions, and your fingers would then be the 3 different axes. The fingers are perpendicular to each other, and the fingers are the axes that is pointing in the direction of different dimensions. Engineers sometimes use their hand to better keep track on these axes as things move around. If you have a 2-dimensional map, you only need 2 fingers to keep track on the different axes, or as we call them, cardinal directions. But you could add 1 finger that could be the direction compared to the cardinal directions. So if you know you need to travel in one direction and you check your cardinal directions using the Nordsydtid, then you need to keep track of the position of the sun. how that correlates with at least one cardinal directions, and lastly, the direction you need to travel. This means you could use one hand and 3 fingers to keep track of this as you go along, until you need to recalibrate by turning the boat back to face the sun. To me, it looks like the rock carvings show that too. Not many rock carvings show the fingers of the portrayed persons, but for these rock carvings, they added fingers on the same persons holding the hornkikare. There are 3 separate parts of these carvings that indicate how they individually could be used for navigation, and together, I think it paints a clear picture. Now for some more possible controversial proposals how this could relate to other known facts. I already discussed how this device could have influenced the watch and how it relates to midday, and how the cardinal directions are of Nordic origin. But there are other things that relate to the worship of the sun and the seasons that the tilted earth produce. There are some indications that the different events that the Nordsydtid showed was and still is important in the Nordic culture. First off, I call the round part jul because the word for wheel in Swedish is jul, but we also celebrate jul during midwinter. Could jul be a name for a round object and the celebrations connected to the round object that shows that it is midwinter? Jul, or midvinterblot, has been celebrated before Swedish became Christian. Is it a coincidence that some Christians celebrate the birth of Jesus at midwinter? Jul is a very important time to celebrate in Sweden, but midsummer is equally important. This is still very much celebrated in Sweden and some other countries. During midsummer, people erect poles that have some resemblance to the Nordsydtid. It looks like the mast with the boom hanging in ropes, but they moved the hjulpot and doubled it, so they hang under the boom. Could this be a remnant from the Nordsydtid, but the understanding of the function has been lost, but people still remember the celebration connected to it? In Great Britain, there are also celebrations where they erect a maypole, and in Germany, they have a slight different pole that is sometimes used in Sweden. This has a pole and the hjul is tilted, but still hangs in ropes from the top of the pole. In Germany, they erect it around the Walpurgis night. This is also celebrated in Sweden, but mostly by burning large bonfires, as is common in several countries in Northern and Eastern Europe. Walpurgis night is not at the time of the equinox, but it would make sense if it originally was. This could have changed date over time, maybe partially when the Julian calendar was exchanged to the Gregorian calendar. This means that the sun does not rise in the east at Walpurgis night, but it does rise in the east around Easter. So is the name Easter to celebrate when the sun rose in the east? Could be that the name comes from a goddess called Eostre, that was a pre-Christian goddess. Her name sounds very much like Östra, that translates to Easter. That it was a goddess could have been a misunderstanding by the monk documenting this, and that it was the direction the sun rises on the day rather than a goddess. Or possibly both. The fourth celebration that would give all 4 cardinal directions one celebration each would have to be in autumn equinox, the most likely being Halloween. Halloween also has pre-Christian origin, and as during the Walpurgis night, it was common to burn large bonfires. There are more connections between the East and West celebrations. On Halloween, people usually dress up in scary costumes, but in Sweden, people dress up as witches during Easter. The fires during Halloween were said to guide dead people and welcome them home for one night. In Sweden, burning of the fires during Walpurgis night is said to scare off witches and evil spirits. So the type of celebrations are somewhat connected. Are these celebrations created as an effect of the invention, or did the Nordsydtid get invented because there already was an understanding of these 4 events? This is hard to say, but it is very likely that some of these events was noted before it could be measured by the Nordsydtid. And this brings us into how they could time these events using Nordsydtid. As already mentioned, the sunrise and sunset formed a sun cross on the days of the equinox. Midwinter and midsummer was a time that the movement of the boom had to change direction. At midsummer, the boom was in its highest position, and midwinter in its lowest position. The movement of the boom up and down the mast would form a calendar. So not only did the Nordsydtid give the user an understanding of the cardinal directions and the forced celebration that we just talked about, but it could also be used to better understand smaller increments, probably down to weeks. Some believe that the word week comes from the same word as Viking, that comes from the word vik, that means bay in Swedish. If you use the Nordsydtid, you would want to calibrate it, probably once a week, and you would have to do it in your home bay or vik, as not to induce error due to the different latitudes. This is possibly connected, but week could also come from the Swedish word vika, that means to fold, or possibly turn over, and this makes more sense. As they move the boom up and down, they could do some markings along the mast, and this would be your calendar. This would look very similar to the rune calendars. These were wooden sticks with engraved dates and had important dates during the year. The origin of the rune calendar could be from the Nordsydtid.
I hope you find this video interesting and watch my other videos, and if you want more details, please buy my book. Thank you for watching, and bye.